In this video, we're going to take a look at section 7.5, which is on graphing quadratic functions in vertex form. The vertex form of a quadratic function is given by the formula f of x equals a times parentheses x minus h squared plus k. The graph of a quadratic function is a parabola. So in this section and the next section we're going to take a look at, we're going to be learning how to graph parabolas. Right? To graph a parabola, so this is what a parabola looks like. Let me draw you a picture real quick, if I can find out how to do that. So it's just going to be kind of a rough sketch here, but so parabolas look something like this. They're kind of U-shaped graphs, and they have a few important features. We're just going to focus on a couple of these for this course, but when you see this topic again in college algebra, there's going to be a deeper dive into this material, and you'll be looking for a lot more detail than what we're going to be doing right now. So the important points that we're going to focus on in this section will be the vertex of the parabola, which would be the point at the very bottom of the parabola in this case. So this would be the vertex. And the symmetry of the graph. So a parabola is symmetric. It's symmetric about the vertical line. If I could draw a vertical line. It's symmetric about the vertical line that passes through the vertex. So this vertical line right here, if you were to fold the parabola along that vertical line, the left-hand side should perfectly match up with the right-hand side. The benefit of this is that for any point that I find on one side of this line of symmetry, there has to be a mirror image point the same distance away on the opposite side of that line of symmetry. So it's kind of like BOGO, right? It's buy one, get one free. So you do the work to get one point, the symmetry gives you another point for free, right? So we'll take advantage of that as we put these graphs together. All right, so how do we find the vertex? Well, oddly enough, this is called the vertex form because of how easily we can extract the vertex from this equation. So let's move on to the next screen. The vertex of a parabola, as I just mentioned for the previous example, was the lowest point on the graph. Parabolas can also be upside down U's, and in that case the vertex is the highest point on the graph. So the vertex will either be the lowest or the highest point on the parabola, depending on which way it's facing. Another way to think of the vertex is as the point where the parabola changes direction. And that doesn't matter which way it's facing, the vertex always plays that role. For the function f of x equals a times x minus h squared plus k, the vertex is simply located at h comma k, which you can read directly off the equation. H is the number being subtracted directly from the x variable inside of that power of 2, and k is just the number that's being tacked on to the end of the function. You grab those two numbers, and that's how you put your vertex together. So very much like getting the slope from a linear equation, right? If you have a linear equation in the form of y equals mx plus b, the slope is just the number in front of x. You just read it straight off the equation. That's what we can do here for the vertex for these quadratic functions. All right, so let's take a look at an example, I guess, as soon as I talk about this last bit. So the axis of symmetry, which is also called the line of symmetry, different textbooks give it a different name. I don't remember which one this textbook likes to use, but I know in college algebra it definitely is axis of symmetry. It's an invisible vertical line that passes through the vertex, as I mentioned earlier in my example I did a couple screens ago, upon which the parabola is symmetric. To describe that vertical line, so let's go back to that example I just did a moment ago. To describe this vertical line, since it is a vertical line, it's going to be x equals some number. The number that it should equal is whatever the x coordinate of the vertex is, because that vertical line should be passing through the vertex. And so the number here should be whatever the x coordinate of the vertex is equal to. And so that is why we have this formula here. So x equals the x coordinate of the vertex is the equation that describes this vertical line of symmetry. And that's how you'll have to answer that when you're doing the homework on Math Excel. If it asks you for the line of symmetry, you'll have to type in x equals a number to describe that line of symmetry. Okay, so now let's take a look at an example. This one's maybe a little bit too simplified. Even though you might disagree with me, you might say, well, that looks like an awful equation. We have the fraction there, and I agree, the fraction is terrible. But a lot of the main components of the equation are missing. So if you compare this equation with the formula, right, we're missing the h, we're missing the k, and so it's hard to match it up to the formula, is the reason that I'm a little bit hesitant about this being the first example, but we'll go ahead and start with this. So it's a little bit too simplified because we're missing the structure of the formula that we would like to see. So if we compare this to the formula, x times, sorry I said x, I don't know why I said x. Let's start with this. F of x equals a times x minus h squared plus k, right? That's the formula for a quadratic function written in vertex form. If you try to line it up with the equation that we were given, the a lines up with the 1 over 16. So the value of a is 1/16. There is some significance to that, but we're not really going to study it that closely in this course. So we're not going to do anything with that value for a. But what we do want to look for is h and k, because that tells me the vertex. And in this case, the h is missing. There's no number here being added or subtracted directly to x. So that means it's equal to 0. So h is equal to 0 in this case. And there's no k here either. There's no number being added or subtracted directly to the end of the equation. And so this is where k would go. Right? And since there's no number there, it must be equal to 0. So my vertex for this particular problem is going to be at 0, 0. The h is missing, the k is missing. That means they're both equal to 0. Therefore, not that the directions are asking me for this, but just to make sure we talk about it, the line of symmetry in this problem is going to be x equals the x coordinate of the vertex, which is 0. And so that's going to be my axis of symmetry, or my line of symmetry. So I can go ahead and plot this point, the vertex, which will be at 0, 0, which is the origin right here. And I know I have a symmetry. I have a line of symmetry, which is the vertical line passing through that point. Let me use a different color here. And I'm probably not going to do the greatest job making this line straight, but here's the axis of symmetry. That wasn't too bad, actually. So the graph, the parabola, will be symmetric to this vertical line right here. But if that's all the information you find, you really don't have enough information here to draw the parabola. We still need to find a couple more points. And to do that, we're going to use this generic method for graphing that we talked about way back several chapters ago, because we haven't done any graphing in quite a while for this course. The last time we did any graphing, I believe, was chapter 2, really. Chapter 3 was system of equations. There was a little bit of graphing in there, but that definitely was not the focus. The last time we really focused on graphing was chapter 2, so months ago. But one method we have for graphing is finding solutions to the equation and plotting them as points. And to find solutions to the equation, we pick a value for x, we plug it into the equation, and then the equation gives us the corresponding value for y. And that by that way, we will get a point. And we can plot it over here, and we'll start to see the pattern. You want to be careful on how you choose your value for x, because it's going to get multiplied by 1/16. We want to pick numbers that will interact nicely with that. And so, for example, we could pick x equals 1, but that doesn't work out so well, right? If we plug 1 into this equation, we'll get f of 1 equals 1/16 times 1 squared, which will be 1/16 times 1, which will be 1/16. You get a solution. It's, again, in theory, there's nothing wrong with this. I mean, what we did here was fine. It gives you a solution. You can plot it as a point. It's just a very difficult point to graph, especially when you're doing it by hand. So 1, 1/16 is going to be just a shade above 0 here, where x is equal to 1. So not very helpful, not very easy to graph. So a good choice for x here that gives us a number that does simplify nicely would be choosing 4 for x. If we pick 4 for x, I'm just going to modify it up here. We'll plug in 4. We'll get, oops, I guess I should change it here too. So we're plugging in 4 for x this time. This will become 4 squared, which will be 16. And then 1/16 times 16, that works out nice, right? We get a nice answer. We get 1. And so that gives me some easy numbers to work with, which on Math Excel really will be necessary. Math Excel will not let you plot this point 1 comma 1/16. It's too, it doesn't do fractions really when you're using the graphing tool. So you have to pick numbers for x that work out nice for y in order for you to be able to graph this point on Math Excel. So 4 comma 1 is a great choice. The numbers work out nice. You can use those numbers on Math Excel. We can use the symmetry to get a point for free, right? So because we have this point here at 4 comma 1, there has to be a mirror image point the same distance away on the other side of the axis of symmetry. So this is 4 to the right of the axis of symmetry. So if I go 4 to the left, I have to find another point there. There has to be a mirror image point the same distance away on the exact opposite side of the axis of symmetry. So I get this point for free. So negative 4 comma 1 would also have to be a point on my graph. Now I believe the way Math Excel works is you have to plot the vertex, right? That's necessary. The first point you plot has to be the vertex. That's what I was trying to say a moment ago. Then you pick a second point, and you get that second point just like we did here. And then Math Excel automatically gets the rest of the parabola right for you. So really on Math Excel, you only need 2 points. You need the vertex first, and then any other random point will do as long as the numbers are nice. And then it automatically draws the rest of the parabola. But when you're doing it by hand, we'll probably want a little bit more information than this to really see that parabola shape. So the next best choice that I can think of for x would be 16. So if I plug in 16 for x here, the numbers get kind of big for a moment, but it works out nice, right? So we'll get 1 over 16 times 16 squared. That's going to be 1 over 16 times 256. When you multiply those together, when you multiply by 1/16, it's like dividing by 16. 256 divided by 16 is going to be 16. And so we get this point here, 16 comma 16. Again, the numbers work out to be nice whole numbers so that we can plot this point on Math Excel as well if we needed to, if you can find it. So it's kind of hard to line it up. So there's 16 comma 16. The symmetry tells me that I should have a mirror image point the same distance away on the left-hand side of the vertical line here, the axis of symmetry. So at negative 16 comma 16, I should find another point there. All right, so it's the same distance away on the right-hand side. On the exact opposite side, sorry, I said the right-hand side for some reason. We go the same distance away on the left-hand side of the axis of symmetry, and we find another point there on the exact opposite side of this point. Right? And so that gives me 5 points here to work with. So this will be at negative 16 comma 16. And then I want to connect these points according to the pattern, and it should be a parabola. All of these quadratic functions, the pattern is a parabola. I'm going to do the best I can. This might not work. This might not look good, but I'm going to try to draw a parabola here the best I can. Oh gosh. Yikes. Okay, I'm going to try. I probably will do worse this time. It's just hard to control this pen. And I'm kind of doing it blind because the pad I use to write is not directly on the screen. So I'm kind of having to figure out where the pen's going to go on the pad to make sure that it shows up on the screen the right way. I don't know. It's hard to explain, but it's kind of difficult to do. And I'm going to do even worse on this one because it's going to the left, and I feel like it's going to be harder for me to write that. Okay, oh gosh. Oh yeah, I was right. Okay. So it's going to look something like that. This is embarrassing, but I think that's the best I'm going to be able to do. So just imagine this being more smoothed out here, and it actually wouldn't look too bad. All right, so that's the graph for this function. Again, on Math Excel, it's going to be a lot easier for you. You just plot the vertex, plot one other point. The hardest part will be choosing a value of x that will work out nice with this function so that y comes out as a whole number as well, right? There's a lot of numbers here you could pick where your answer comes out as a fraction. So you have to be very careful to choose a value for x that simplifies nicely and gives you a whole number for y. As long as you can find one of those, Math Excel will plot the rest of it for you. It'll draw on the parabola for you so you don't have to plot any more points yourself. When you're doing this on my exam, however, you won't have Math Excel's graphing tool to do that for you. So this is what I expect to see, except maybe something a little bit better drawn here. This is what I expect to see on the test. plot a few points. Plot at least 2 over here. Use the symmetry to get these 2 for free. And that really does a good job of defining the parabola. All right, let's take a look at another example. So here, if we compare this to our formula, we have f of x equals a times x minus h squared plus k. In this case, since there's no number in front of the parentheses, it's an invisible 1. So a is equal to 1, which we're not going to do anything with. Like I said, it does have some significance, but we're not going to bother with it in this section. What we're really looking for here is the vertex. Right? And so the vertex is at h comma k. Let's start with k because I think that's just going to be the easier one to identify. There's no number here, so k is equal to 0. Right? So if that number is just completely missing, k is equal to 0. However, in this case, h is not missing, right? We do actually have a number here. And it's a very common mistake for students to say h is equal to 12. And so I'll oftentimes see 12 as the answer here, and that is not correct. And a good way to check your guess here is to take whatever you think h is equal to and plug it into the formula. If I plug in 12 here for h, what do I get? I'll get x minus 12 squared. But my equation has x plus 12 squared. So if I want this to come out positive, I have to plug in negative 12 for h, not positive 12. So if I plug in negative 12 for h, then I will get x minus negative 12 squared. The double negative will make that positive. And then it matches up to my equation. So h actually needs to be negative 12 in this case. The same is not true for k. K actually will keep the same sign of whatever number happens to be here. We'll get to an example of that here in a few minutes. But for h, a common way for students to remember this is they take the opposite sign of whatever number, they take the opposite sign of whatever is actually in the equation. So if we have positive 12 here in the equation, h needs to be negative 12. If we had negative 12 here in the equation, h would need to be positive 12. So h will be the opposite sign of whatever this number is here. Okay, so we'll have negative 12 for h and 0 for k. So there's my vertex. That is either the top or the bottom of the parabola that I'm trying to graph. So let's go ahead and plot that point. It'll be at negative 12 comma 0, which will be right here. That means the line of symmetry, or the axis of symmetry, whatever they want to call it, it looks like they are calling it axis of symmetry here, will be at x equals the x-coordinate of the vertex, which is negative 12. Right, so that's how we will identify the line of symmetry. So when Math Excel asks you to type in the line of symmetry, this is what you need to type in, x equals negative 12. It's a vertical line that passes through the vertex. All right, so it's this vertical line right here. So the parabola will be symmetric to this vertical line. Just like in the last example, this information alone is not enough to know exactly what the graph looks like. We have to plot a couple of points. Using the Math Excel graphing tool, you really just need one more point. The vertex and one other point, Math Excel will get the rest of the graph correct for you. But on paper, we probably should plot at least a couple of more points over here and use the line of symmetry to get a couple more points for free, and then we'll have a good sense of what the parabola looks like. This one, it's going to be a little bit easier plugging numbers in for x because there's no fractions involved, so we should be fine whatever we want to pick. But if you go too far away from the vertex, the numbers become extremely big. And we can't really accommodate really large numbers. This graph only goes up to 20, so I don't want to stray too far from the vertex. So if I were to choose like x equals 1, that's pretty far away from the vertex. Go ahead and try it out. If I plug in 1 here for x, I'll get f of 1 equals, sorry, I don't know why I'm putting x there. We'll get 1 plus 12 squared, which will be 13 squared, which will be 169. Right? We definitely don't have room for that result in our graph. So stick close to the vertex when you're plotting points. So I'll pick negative 11. That's pretty close to negative 12. All right, so I'll plug negative 11 in for x. We'll get negative 11 plus 12 squared. That's going to be 1 squared, which will just be 1. All right, so we get a nice, simple, small result that we can go ahead and plot. So we have Negative 11 comma 1 would be this point right here. On Math Excel, once you plot that second point, it'll draw the rest of the parabola for you. But on paper, I would like a little more guidance, so I'd like a couple more points. One point that we can get for free is using the symmetry. So I went 1 to the right of the axis of symmetry, and I got this point here at y equals 1. There should be a mirror image point the same distance away on the exact opposite side of the axis of symmetry. So if I go 1 to the left of the axis of symmetry, I should get another point there at y equals 1 as well. So going 1 to the left would put me at negative 13. So if I go 1 to the left of the axis of symmetry to negative 13, I should get the same answer for y. And that gives me these two mirror image points. Let's get one more point over here. Maybe I'll go a little bit further away. Let's say like negative 9. You don't want to go too far away. The numbers get big pretty quick. So let's plug in negative 9 here. I'm running out of space to do this. I guess I could do it over here. I'm not going to be using this part of the graph anyways. So I have f of negative 9 equals negative 9 plus 12. Sorry, I've written too much on the screen here. So negative 9 plus 12 squared, which gives me 3 squared, which gives me 9. So I get negative 9 comma 9. So let's see if I can line this up okay here. It looks like it'll be about right here, if I got that right. And then I can use the symmetry to get a point for free. So here I'm 3 to the right of the axis of symmetry. So if I go 3 to the left, I should get a mirror image point there. So 3 to the left will be at negative 15. All right. And then with those 5 points, you get a pretty clear sense of what this parabola looks like. So I'm going to do the hardest part for me, which is connect these points in a parabolic shape. On paper, I would do a lot better with this, but on this screen with this writing pad that I have, it's really tough to do. Okay, that wasn't the worst, but again, it should be a little smoother drawn than this, but you get the idea. All right, and so that's what the graph looks like for this equation. Let's take a look at another example. All right. So this one's pretty similar, except we have another fraction to deal with. So it's kind of a combination of the last two examples that we looked at. The vertex here is going to be at, why don't you pause the video for a moment and consider what do you think the vertex should be, and then resume the video to see if you came up with the right answer. The vertex should be negative 4 comma 0. So again, comparing it to this formula, that's the formula we're comparing it to. A is equal to negative 3/2. We're not doing anything with that information, but that's what lines up with A in the formula. H is going to be negative 4. So again, it's the opposite sign of the number that's actually given in the equation. There's a positive 4 here, and so H will be the opposite sign of that. It'll be negative 4. And then K is missing, so that means it's equal to 0. So the vertex is negative 4 comma 0. The line of symmetry is going to be, I shouldn't do equal sign there. Let's do it like this. It's going to be x equals negative 4. So whatever the x coordinate of the vertex is, that'll be the axis of symmetry. X equals that number. So again, let's plot that point. We have negative 4 comma 0. All right. And then we have the axis of symmetry. Let's see if I can draw it this time. I've done pretty well so far today with drawing vertical lines. Not so well with parabolas. Okay, now I jinxed myself. Let's try that again. All right, let's keep going straight down. Okay, pretty close. All right, so there's my axis of symmetry, which on Math Excel you don't need to draw in. You don't need to draw that vertical line. As I mentioned in the definition, it's an invisible line. So it's there, but you don't really see it in the graph. But it's something you should be aware of because it will help you with finding more points, right? So we need to plot a few more points. We want to choose carefully here, so let's just put it up here. Right. Stay close to the vertex, but pick numbers that will get multiplied nicely by the negative 3/2. When your denominator is a 2, what's ultimately going to happen is the answer you get here will have to get divided by 2. And so you want to pick numbers here that can be divided by 2, which means you want even numbers. Which means, in this situation anyways, I should pick values for x that are even numbers, because when I add by 4, it'll stay even, and by having an even number squared, that'll stay even, and then even number divided by 2 will work out nice. If I pick an odd number for x, when I add 4 to it, the answer comes out odd, and when I square an odd number, I get an odd result, and then it won't divide nicely by 2. So picking an even number for x should make this work out nice. So you have to do a little bit of planning to make sure the answer works out nice. Or even if you don't want to do that planning, just be willing to pick several values for x until you find one that works out nice. So if you pick 3 here, for example, it works out to be a fraction, then pick 4 and see how that works out. And then pick 5, and you'll alternate. One will be a fraction, one will be a whole number, one will be a fraction, but you'll eventually get points that you can use if you just pick a few different values for x. But if you don't want to get numbers you can't use, you want to plan ahead a little bit. So I'm not going to pick 4 though, because that's going to be kind of a big number. I want to stick close to the vertex, so I'm going to pick -2. That keeps me close to the vertex, so the number should stay kind of small, and because it's an even number, I think this will work out nicely. All right, so let's plug in -2 here. We'll get -3/2 times -2 plus 4 squared, and then we're going to simplify, so we'll get -3/2 times 2 squared, which will be -3/2 times 4. What's going to happen here is 4 gets divided by 2, which gives me 2, and then I multiply by -3, so I get -6. So it works out pretty nice, right? We get -2 comma -6, and this one's actually going in the opposite direction of what we saw in the last couple of examples, right? So this parabola will actually be upside down. Again, we didn't really talk about this, but the way you could know this is going to happen is when a is negative. When a is a negative number, the parabola is going to be flipped upside down. When a is positive, it's going to be right side up. We can use the symmetry here, so we went 2 to the right to get this particular point. If we go 2 to the left, we should find a mirror image point over here. So 2 to the left, which is at -6, comma -6. Again, Math Excel, that's all you need to graph the parabola, but I think one more would be good for us when we're doing it by hand. So I'll choose another even number. I'll pick 0. 0 is really considered an even number. And plug that in here. So I need a little more room, so I guess I'll do it over here. Plug in 0, so we get -3/2 times 0 plus 4 squared. It's going to be -3/2 times 4 squared, which will be -3/2 times 16. 16 divided by 2 gives me 8. 8 times -3 gives me -24, which actually doesn't really help me here, does it? Because I only go down to 20, and even 20 is a little bit off the recording screen, so you can't quite even see that. So I really can't use that point, unfortunately, but I do know it's going to be down here, right? 0 comma -24 is going to be below what I have here. So I shouldn't cross my y-axis within view here. It doesn't cross the y-axis until it gets down to -24. So I'm going to stay on this side of the y-axis when I draw this parabola. So let's try to draw this here the best we can. So pass through that point. Okay, this might be, maybe it's easier for me to draw them upside down than right side up. All right, so that actually worked out pretty good. All right, so this is what the graph should look like. The symmetry, if I went 4 to the right to get -24. So if I go 4 to the left, that'll be at -8. I get the same value for y, I get -24. So that'd be another point that we could, again, if we had room for it, we could have got 2 points out of that work, right? So we do the work for 1 point, we get this other point for free. All right, so that's what that graph looks like. Okay, so let's take a look. I think I have 2 more examples here for us to try. Graph the following function and find the vertex, the axis of symmetry. And this time we have an additional request. They want us to find the maximum or minimum value of this function, which happens at the vertex. So we really don't have to do any extra work on this problem. We just have to identify something that we already have the information for. So the maximum or the minimum value is the highest or the lowest point on the graph, which occurs at the vertex. So let's find the vertex here. This time we actually do have a value for k. So here's the formula we're comparing to. F of x equals a times x minus h squared plus k. A is equal to 1. Again, we're not really doing anything with that in this section. H is equal to +3. So again, we have a -3 here. H will be the opposite sign of that number, so H will be +3. And here we have 8 matching up with k. And for k, it keeps the same sign of the number that is here, right? There's a plus sign in front of the k, so there's no crazy negative sign stuff going on. K just is the number that you see over here on the end of the function. It's positive 8. So my vertex is at 3, 8 in this case. My axis of symmetry is going to be at x equals 3. So it's going to be x equals whatever the x-coordinate of the vertex is. So we have the point 3, 8, which is going to be located right here. And then we have the axis of symmetry, which is the vertical line that passes through the vertex. All right. Okay, so very good. Now, whether it's a maximum or a minimum depends on if the parabola is going to be right side up or if it's going to be upside down. I mentioned on the last example, the value of a determines what that will be. Since a is positive in this case, it's actually going to be right side up, which means this vertex will be a minimum. The vertex is at the bottom of the parabola, which means it is a minimum value. If it's upside down, the vertex would be a maximum because it would be at the top of the parabola. All right, let's go ahead and finish graphing the parabola first, and then we will identify the maximum or minimum value. So we'll finish graphing by doing the same thing we did on the other examples. We need to plot a couple of points. This time, since we don't have any fractions to worry about, we should be pretty free to pick whatever values we want for x. I would recommend staying in the vicinity, of the vertex. So the vertex is at x equals 3, so I wouldn't stray too far away from that. 0 isn't too far away, so I think 0 is a nice choice if it isn't too far away from the vertex. So I'll choose 0 for x. Let's plug that in and see what happens. So we'll have f of 0 equals 0 minus 3 squared plus 8. That's going to be negative 3 squared plus 8, which will be 9 plus 8, which will be 17. All right, so negative 3 squared is positive 9. 9 plus 8 will give me 17, which does barely fit within my graph window. So we have 0, 17. That was 3 to the left of the axis of symmetry. So if I go 3 to the right, I should also have a point at y equals 17. So 3 to the right would be at 6. This is going to be right here. So that's 3 to the right of the axis of symmetry. I'll get another point with a y coordinate of 17. So it's going to be 6, 17. So I get that point for free. I just go the same distance away on the other side of the axis of symmetry, and I mark another point there. Let's get one more point. I mean, that does a pretty good job of finding the graph. I don't know, I feel like I'm a little bit off the mark here. It doesn't look right to me. So it looks like it's at 6. Yeah, maybe I'm just drawing that point too big. All right, or my axis of symmetry is a little bit off. It's a little bit crooked here, so, but I think I have it in the right spot. Let's pick x equals 4. All right, we'll just, that's pretty close to the vertex. We'll plug in 4 here. I'm just going to do it right here. We'll plug in 4 for x. We get 4 minus 3, which is 1. 1 squared is going to give me 1. I get 1 plus 8, which will be 9. Right? So we get 4, 9, which will be pretty close to the vertex right here. The symmetry, if I go, that's 1 to the right of the axis of symmetry. If I go 1 to the left, I get another point at 9. And so that'll be 2, 9. Right? And with those 5 points, you get a pretty good sense of the parabola. So let me try to draw that. Maybe I'll start up here. I might do a better job if I do it that way. No, I'm not doing too good. Let's try it again. Okay, not too bad, not too bad. Okay, that was a little bit better than what I had done previously. All right, now I think it's pretty clear now that I've drawn in the graph. The vertex is at the bottom, which makes it a minimum. There is no maximum in this graph because the graph keeps going up forever. So there is no maximum. It goes to infinity. But there is a minimum. There is a place where it bottoms out. And so it's going to ask you to choose. Is it a maximum or is it a minimum? We're going to choose minimum in this case. And the minimum value is the minimum y value, which is the y coordinate of the vertex, which is going to be 8. That's as low as the graph goes. It goes no lower than 8. So that is the minimum y value for this function. This equation cannot produce any y values less than 8. It just is impossible to do. It only goes as low as 8. It won't go any lower. So the minimum value of this function is y equals 8. And that's what you'll need to type into Math Excel. All right, I think I have one more example here for us to look at. And so it's pretty similar to the one that we just did. So this time though, A is negative, so it's going to open down. Hopefully it'll fit in the window that I have here. So let's see, -4, oh, it's going to be kind of close, but let's just try it. So again, comparing this to the formula, we have A times x minus h squared plus k. All right, so see if you can find this information. What is the vertex? And what is the axis of symmetry? All right, so pause the video, see if you can identify that, and then resume the video to see if you came up with the right response. So the vertex, h in this case, because we have a positive 5 here, h will be -5 for the vertex. And k will keep the same sign, so k will be +4. So we get -5, comma 4, which is going to be this point right here. The axis of symmetry will be at x equals -5. So I'll draw a vertical line representing that axis of symmetry. It's a vertical line that passes through -5, passes through the vertex. So that's this vertical line here, x equals -5. Now, if you will, pause the video, plot a couple of points around the vertex to see the shape of the parabola. Again, it's going to open down this time, so it's going to go this way. But plot a couple of points so you can see the parabola, the shape of the parabola. And again, the way you plot a couple points, you pick a couple values for x. Again, you don't have to be too careful here because there's no fraction, but you do want to be a little bit careful because by multiplying it by -2, these numbers are going to get big even faster. So if you pick, like 0 might not seem too far away, but I think if you pick 0, you're going to get a really big number. It won't fit in the window of my graph. So stick close to the vertex, and you should be able to pick whatever number you want close to the vertex and get usable numbers for the graph. All right, so pause the video and then resume it once you have a couple of points that you can plot. I'm going to choose -4. I'm sticking really close to the vertex here. So if we plug in -4 there, get f of -4 equals -2 times -4 plus 5 squared plus 4. That's going to be -2 times 1 squared plus 4. That's going to be -2 plus 4, which will be +2. Right. So that stays pretty reasonable. I thought it might be a bigger number than that. So we're going to get -4 comma 2, which is right here. That's 1 to the right of the axis of symmetry. So if I go 1 to the left of the axis of symmetry, I get a mirror image point there. All right, and then we should find another one. Let's say we pick -3. I'm really afraid to go too far away. So let's pick -3. So I'm going to do, let me see if I can just erase here. I don't know if I can, let's pick a different eraser size. So I'm going to pick -3 here. So let's erase that. We'll erase that one. And so let's see what happens when we plug in -3. Let's pick a different color here. So we're plugging in -3 for x. -3 plus 5 gives me 2. 2 squared is going to be 4. -2 times 4 make that a -8. So let's erase that. So this will be -8 plus 4, which is going to give me -4. So we get -4 here. So we get -3 comma -4, and so you can see that this is pretty dramatically dropping. And if I had picked -2, for example, I think it fit, but just barely. So we plugged in -2 here, we would get 9. 9 times 2 is -18. I get -14. It barely fit on the screen. But all right, so that's 2 to the right. So if I go 2 to the left, I would get a mirror image point right there. And so there's my parabola. Let's connect those points here. So we'll have into a parabolic shape. Don't make it a V shape. Don't make it jagged. It should be smooth, rounded curves here. And again, you probably should have better luck doing it on your paper than I'm having on the screen here. So this is what the parabola looks like. This time, the parabola has a maximum value, right? The vertex is at the top of the graph, so it tops out here at y equals 4. And that's a maximum. It doesn't go any higher than that. That's the maximum value that you get on this graph. There is no minimum because the parabola goes down forever. So this time we have a maximum value, and that maximum value is at y equals 4. That's as high up as it will go. It won't go any higher than that. All right, so that concludes the video on section 7.5, graphing quadratic functions in vertex form.